Buddy, good time zone wherever you are in the world. Welcome to OWASP October with APIsec U. I see Mergonk in chat already. First guy to reply. Good to see you, Mergonk, as always. Abdullah, good to see you. Sammy, William, Danny, nice. From Malaysia. Very cool. Awesome. Well, thank you guys so much for joining us today. Super excited to see you all. We're going to be continuing what we've been doing with OWASP October today, and that is going over the OWASP Top 10. And today we're going over number 7, server-side request forgery. And I've brought along with me a dear friend of mine, a mentor, and one of my just favorite people to work with, Mr. Al-Amir Badmus. Thanks for joining us today, Al-Amir.
Thank you very much, Jesse.
Yeah, absolutely. Nigeria. You're in Nigeria as well, right, Al-Amir?
Yeah.
Yeah, nice. We got some locals around you in here chat today. Very cool. So I'm going to go ahead and get us kicked off, you guys. And what I'll be going over is just sort of what SSRF is, a little description about it, and then kind of covering some examples that we've seen in the wild, some actual large breaches or a large breach that occurred, and then another potential breach that wasn't, thankfully, some ethical hackers found first, but it's still worth talking about. So I'm going to go ahead and bring my slides up to the screen here, and we'll get right into it. Our possessed requests is our theme today, sticking with the Halloween bad guys. I think we had Freddy Krueger last week. I've been digging all this stuff. Shout out to Christine. She did a ton of hard work putting all this stuff together for us to keep it fun. But let's go ahead and talk about it, right? OWASP API number 7, server-side request forgery. So what is it exactly, right? Well, there we go. Server-side request forgery occurs when an attacker can make the server perform unintended requests to internal or external resources, right? So a simple explanation of this is, I guess you could think about it this way. Normally, when you use an application, you make requests to servers, but sometimes those applications fetch data from other places based on URLs that you're providing to the application, right? And so an SSRF vulnerability exists when the application doesn't properly validate those inputs. It allows the attacker to manipulate where the server is making those requests. And so an analogy of how that would work is, imagine if like you lived in a neighborhood that had like a robot personal assistant that helped everybody out, right? He would come in, he would clean your house for you, he might go run errands for you, right? And he does this for everybody in the neighborhood, no questions asked, super handy. So, right, you might tell him, hey, go to the store, pick me up some grapes. No problem. He's going to go do that for you perfectly within bounds. He trusts you, you trust him, everything's good. But then what happens if you ask him, hey, go to my neighbor's house and grab their diary from the bedside table, right? Well, he's going to trust you, just like the API call would. And just like the application is going to trust the API call, right? Your neighbor's house might be the resource, and he's going to go, oh, hey, the servant robot's here. I see that guy all the time. He's just here to grab something that he normally would. But what he's actually there for is something that doesn't belong to him, right? Hopefully that helps make sense for people that are a little maybe early on in their journey in discovering vulnerabilities. Are we having sound issues? I don't know. Can everyone hear me okay? Are we having sound issues?
Yeah, I can hear you, Jesse.
Sound is fine. I can hear you fine. Okay. Try refreshing the page, guys, if you can't hear me. Sometimes that tends to be the issue. All right. So server-side request forgery is super duper dangerous. A lot of the times because the server has access to, all sorts of stuff, whether that be functions, data that you don't want other people seeing. It could be records of all different kinds. I know I'll talk about some examples here in just a moment. Al-Amir, have you seen any server-side request forgery vulnerabilities recently that were interesting to you, just out of curiosity?
Yeah, of course. I think there was a time I was doing a pen test, and like it was a web pen test, right? But the application was hosted on a cloud platform, and allowing a user supplied compute. And I first of all tried it with google.com, and when I checked the response body, I could see some data from Google, and it gave me the idea that I think this server is making a request on my behalf. And
Interesting.
I think I can try to see if it is vulnerable to SSRF. And I'm just trying to call some popular cloud endpoints for Azure. And, luckily for me, I was able to get like sensitive keys that are not meant to be exposed, basically. Yeah, so.
Really interesting. So you actually tested by using Google to see if that was going on. That's cool. ChatGPT SSRF. Oh, I haven't heard about that one, Rafat. I'm gonna have to Google that after this, actually. But what I do want to talk about is Capital One's breach in 2019, because this was one of the biggest examples of SSRF. And so what happened with Capital One is they had I believe it was AWS, it was an AWS platform, right? And this graphic that I'm displaying here, hopefully this is big enough. I should have made that picture a little bit bigger. I will give you guys at the end of this, my graphics today are all pulled from articles that cover these breaches in really great detail. I'm not going to spend a ton of time. We only have to have a half hour today, and I really want you guys to be able to see the demo piece, because Al-Amir is going to actually show you guys what it looks like to hunt for an SSRF vulnerability on an application. And I think that's going to be the most enlightening thing here. And yes, there absolutely will be a recording of this session, 100%. Okay, so let's talk about this graphic a little bit though, right? Because there's main points that happen here, right? The initial access point. So first, the attacker used anonymizing services, which is this Tor piece over here, the VPN service, to just remain anonymous, right? And they sat in the environment anonymous, looking at things, looking for misconfigurations, right? You can't hear me. Why are so many people having issues with sound today? On Safari, Chrome. That's so strange.
I can hold it. So.
Yeah, I'm just going to put a quick message in chat here.
Yeah.
Sorry, guys. If you can't hear me, try switching devices and stuff. Anyway, so being anonymous and figuring out where the misconfiguration is piece one, right? The misconfiguration in the WAF is piece two, right? It's running in reverse proxy mode, and that is able to be exploited. 3 is the credential theft. So the attacker queried the AWS metadata service through the compromised WAF. He figured out the misconfiguration. He goes through the WAF, queries the metadata service, and figures out that he has an overprivileged role, right? And so he gets that credential back, because that's what that service is supposed to do. The service that he hit that he's not supposed to have access to, the WAF should have been blocking him, returns that credential to him. Okay. Now, using that credential, he's able to just exfiltrate data in mass, because that IAM role is way overprivileged for what he should have been doing. And here's just a little bit simplified version of this, so that you guys can understand what's going on there a little bit better, right? You make a request, the vulnerable application receives that manipulated request and processes it. The malicious request is executed by the application. Bingo, you're through. This happened somewhere else too, though, that I thought was interesting, and I wanted to talk about it because of the fact that we're doing the overall top 10 for October, and that's the Lego attack. Because Lego was actually a chain sequence that led to the SSRF. Now, there wasn't impact here because ethical hackers found it first, thankfully, and reported it. But still another great example. So it all started with XSS, actually, in this case with Lego. They found an XSS vulnerability in this find username field here you see in the middle of the screen. Shout outs to Salt. Again, I'll include a link to this for everybody at the end of this. That XSS vulnerability allowed them to take over an account. So with that account takeover, now they find that they're able to do an XXE injection attack. And with that attack, they're able to chain into the SSRF, right? That SSRF, once they get to that point, that's the keys to the castle. Now they're exfiltrating whatever data they want. They're doing all sorts of stuff in there. Like account takeover, obviously bad, but you can see how when you leave these things open, like one thing after another, exactly, the Legos fall into. I'm so glad somebody made that joke. You made it before I could. I was actually going to make that, but that's okay. Good job, chat. That's what happens when you have hackers in chat. Yeah, no, exactly. All the bricks fell into place, 100%. And that's the danger of the top 10 and why we're taking the time to do a session for you guys on each of these. Yeah, I can definitely share these slides after the session if you'd like me to, no problem. These ones are pretty low effort. The most important thing from these slides are going to be the sources, because all of the source material is what these slides were built from, and that's where the real info is. So I'll definitely make sure you guys get that. But at this point, we're 10 minutes in, so I want to hand off to you, Al-Amir, if you want to take over and show these guys what you've built and what you're going to be testing for us today. I'm going to pull my presentation off screen. And then if you want to present yours when you're ready. Do we have any questions while Al-Amir set up? May I please know what reliable indicators of SSRF in logs or alert? Like how do I? Yes, absolutely. I will get to that later, actually, towards the end. After Al-Amir does his demo, we're going to talk about prevention. And I have a slide with a whole bunch of prevention techniques that has exactly what you're asking for on it. When I try SSF, an origin refer and other parameters is stored and shown in response. Is this a sign of a vuln or not? It's a good question.
I don't think that's an indication of SSRF. It's more cross origin resource. Yeah, exactly. Cross issue.
Yeah, cross origin resource sharing.
Yeah, exactly. Yes. Sorry, Jesse, go ahead.
Go ahead. No, I was just going to say that the cores is like an issue. It is something that's potentially exploitable, but you typically have to be on the same network as the person to be able to do it.
Yeah, just to add to what Jesse has explained. So if you're very new to web exploitation or API hacking, or maybe you recently started and you've done maybe some client-side exploitations and you understand what CSRF is. If you know what CSRF is, then you should be able to understand what SSRF is, right? So I'll just give us a very short explanation of what CSRF is. Then we'll try to see if I can explain SSRF from CSRF, basically. With CSRF, your target is the client, right? Your target is maybe another user who is authenticated or who has like a valid session, and you just want to send maybe a malicious payload to them, and they will execute that request on your own behalf, but it will be from their own end, basically. When they are logged into a place where maybe you don't have access to, and that payload that you've sent to them was able to run, and it performed a certain action that you would not be able to perform on a normal day, but they could perform that action. Say a normal user and an admin, and you're able to target an admin, and you successfully used an admin session to do whatever thing that you want to do. So for SSRF, instead of the client, right? CSRF stands for client-side request forgery, while SSRF stands for server-side request forgery. Instead of targeting the clients, for SSRF, you target the server. I have a demo I'm actually going to show us like very soon, but I want us to understand something before I start the demo, right? Maybe you've tried exploring an application in the past where you have an option to import a file, and it's giving you an option, can you import via URL, like import via URL, right? And now you now have access to feed it a URL. What the server is going to do actually is to take that URL and make requests to the server that is hosting that URL on your behalf. And whatever resource that it needs to fetch from that server, the server will make the request to the other server. It will fetch that resource and it is going to store it on its own server, right? If you now send it to a malicious, if you give it a malicious URL or you send it to a malicious place, it's going to fetch that resource from that malicious place and it's going to store it on its own disk or wherever it's going to store something on, and you can do whatever thing that you want to do.
Right.
Yeah, exactly, right? One of the popular ways we exploit SSRF is to get the server to send a request to itself. And that's actually what I'm going to show us today, because there are so many files that's sensitive that you from the outside, like from the external network or from the internet, cannot make direct requests to. You won't get any valid response. Maybe you get 404, you get 403, it's not found. Yeah, okay, 404, not found, basically, right? Because you won't be able to get access to it. But if you send the server to make that request on your behalf, the server will be able to gain access to such data and it's going to serve you that data. So I added, Jesse, please, can you share my screen?
Yeah, at the bottom left, Al-Amir, you can click present anything. And then a little, yeah, you should have a little studio thing down at the bottom left. You might have to bring it up a little.
Okay. All right. Please let me know when you can see my screen.
I'll bring that to the screen for you. Yep, you should be good now.
Awesome. Okay. All right. If you don't know VolnBank, VolnBank is an intentionally vulnerable banking application I built to teach anyone about common API vulnerabilities, from broken object level authorization to security misconfiguration or SSRF, OWASP Top 10 basically. And I will be showing us how we can exploit demo today, SSRF today. Is my screen still visible?
Yep, we see the Vuln Bank app right now.
Awesome. So I'm just going to register. Let me create an account with JC.
VolnBank is something you all can access in chat, by the way. So after watching
Yeah,
do this, if this is something
exactly.
you guys want to go do. But Al-Amir's you're the creator, right, Al-Amir, of VolnBank?
Yes, I do
Yeah.
have VolnBank actually. So we're going to log in. We've created an account with JC. Now we've logged in. We got welcome back JC, and we have a balance of $1,000. As you can see, we have two options here. You can either click on this and pick any image to represent your profile picture, or you can import from a URL. In our own case, we are going to try to see if we can import from a URL. So I have a free page here. I can just open this one, copy the URL, copy image link, go back to VolnBank, and I'll paste the URL, right? If I paste it, I expect the image to come up. And as you can see, I've been able to import a picture just by feeding it the URL, right? So if we go to the requests, we've been able to capture the requests. And if we go to the requests, we can see that we fed it this URL, and the server made a request to the URL, fetched the file, fetched this file from pexels, and it stored the file in its own static folder, right? In its own upload folder, as you can see. So meaning there's a potential maybe SSRF. And just to add that we have two types of SSRF. We have the blind SSRF and the in-band SSRF. So to test for the blind, I think we can quickly do for blind. If you've done the API security pen test course where Corey took, you should be familiar with webhook sites. It allows you to see if the server is making a request to another server, right? So just to test for blind SSRF, all we need to do is to copy this URL, feed it to VolnBank, and if we get any request here, then it tells us that it's prone to server-side request forgery, basically. So if we go back, click on imports, I'll paste the URL and I'll hit OK. And as you can see, the picture has disappeared. And if we go to the requests, you can see the URL we sent to it, and it also stored the file somewhere, and it tried to make a request to that file. You can see it here, and we got this URL has no default content configured, blah, 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 blah. If we are able to get this same version on webhook, then it tells us that the application is vulnerable to blind SSRF. And as you can see, back to this page, we can see that we got a request, and there's an indication that request was made from the server. You can see Python request 3.1 exactly. This VolnBank was built in Python. So there's an indication that...
What other things might you see there, Al-Amir, on other servers and stuff other than Python? What sort of data would you find indicator?
Exactly. Apart from the user agents, some applications will return like the response body here. Yeah, exactly. And sometimes you can also see like this IP address. I'm not sure if this IP is VolnBank's IP. These are things that you can
on that, figure out where it's coming from. Yeah.
This app you can check for to tell you that, okay, I think a request is coming from the server. And if I click on this URL has no default content. As you can see, we got the same response straight. So now that we know that, okay, there's possible SSRF here, now let's try to see if we can exploit SSRF to filtrate sensitive data or maybe cloud configuration files and all of those things, basically. So if we go back to...
I'm glad you brought that up, Al-Amir, because that's something people need to understand with SSRF too, is like, once you validated that it's possible, the next step is figuring out what you can do with it, because there are potential defensive measures in place. Even if you do get to the point where Al-Amir is now, that doesn't necessarily mean in a real situation he would be able to have impact. So what Al-Amir is going to show you now is what that impact would actually look like.
Exactly. Not every real world application would be like VolnBank, right? So developers would have made sure they try their best to make sure that the field is secure, or maybe there are sanitizing imputes, or maybe there is WAF that is looking out for malicious payloads like that. And there are several ways that you can obfuscate these payloads, right? We won't go into that today. We are just going to see, let's see if we can make let's see if we can make the server, we can get the server to make requests to Google, just like I did in the past. https google.com, we send, and we also got imported URL successfully. If we go back to Bob Suite, you can see that we gave it the Google URL, it saved it, and it tried to fetch the content. And as you can see, it's made a request to Google. We can see Google and all those static files basically. So this is another indicator that this is vulnerable to SSRF. So now there are payloads that there are SSRF payloads that you can use. It depends on if you have, maybe if you've done maybe some recon and is a cloud service that the application is running on, you can try to guess some paths, some common metadata paths, or maybe some common internal paths. In our case, we will try to see, can we get the server to make a request to itself? Let's try vulnbank.org/ let's try internal. Internal is another common place that we can look out for. And as you can see, we get failed to fetch URL HTTP 404. It's trying to tell me something, basically. So I will keep on trying HTTP. So because of time, right? Most developers make mistake of allowing loopback IP, your 127.0.0.1, localhost 0.0.0.0, and whatever loopback IP that the server will need to be able to communicate with some internal system. In our own case, like the common loopback IP is 127.0.0.1. So we'll try again, internal. Okay. And as you can see, we got a different error, HTTP, blah, 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 port 80. Okay. So we need to add ports to it. And it has given me an idea regarding the ports I might need to look out for. 0.1 ports. Let's try 5,000. Let's try 5,000 internal. I'm just going to copy this because of next time. And now we are getting another, we'll stop getting the other error. Now we are getting the previous error we're getting. Let's check the response body. We got 500 here. We got 400 here. Fails to fetch URL. What you can do, internal is a folder. In a folder, there are several files under internal. It could be config, it could be keys, it could be secrets, it could be any of those things, right? We can either send this to intruder and try to brute force this endpoint. So I can just try to see, I can see P, and I'll highlight, add, simple list, and we can add possible or common words that we might want to look out for. I'll add config, I'll add secrets, key, keys. What else can we add? .aws. Yeah, I think this is okay. I will remove the URL encoding and I'll send start attack. It's a demo version, so why can't I send a request to intruder? I guess it's because I'm using free version or something. So instead, we are going to do this manually, guys. I'm sorry, we will have to do it manually. So if we go back,
this has been happening to me sometimes too with burp, where my attack won't start.
Yeah, exactly. So we'll try config. Let's see. We got HTTP 404. We'll try secrets. And as you can see, we got another imported successfully, meaning there's something. Let's go back to proxy.
This is exactly what I was describing earlier, guys. Once you confirm the SSRF, you have to look up to figure out what you can do with it.
Exactly. The one with 200, we sent secrets and it made a request to itself. And I think it got, which means there is a file called secrets for it to give us a 200 OK. And it saved that file in its upload folder. And I think it's made a request to that file here. And if we check the response body, guys, and as you can see, we were able to get a secret. So the server made a request to a file called secrets internally, and it stored that request in a file that we can access over the internet, basically. And as you can see, we have app secret key, DB, and all of those things. So let's try to see if you can find maybe cloud. If you're testing an application or you're doing a cloud pen test, SSRF are also things that you might want to look out for, because with SSRF, you can get cloud, you can get configuration keys, secret keys, access keys, and you can maybe AWS CLI and on all of those things, and you can start escalating your privilege, basically. One of the common paths, like I said, is I think latest slash metadata, latest slash things like that. So we are also going to, we'll try, and I'll add latest to this. Let me copy and send. We got 404. I will add metadata and I'll send. And as you can see, we got imported from URL successfully, which means something is also here. Let's go check. We sent slash latest metadata and it stored the file. If we check the request it made, and as you can see, guys, it's returned a bunch of maybe folders or files that are under metadata. And now that I know that, okay, these are the files, I can copy this and I will send the request again, right? AMI -ID. So if we go back, metadata /AM, I'll just copy this and I'll send. We got a successful response, and it also showed that there's another thing here. Okay, so let's go back again and try slash. I'll just copy, paste. Okay. We got 404. Okay, let's try, because of time, let's try another place.
You're good, man. You got 2 more minutes.
Okay. So let's try IAM. Everyone is familiar with IAM. Let's try to see if we can get keys and stuff. So if you go, HTTP.
I have a few questions waiting in chat, guys. I promise I haven't forgotten you.
101 ports 5000 /latest /metadata and /IAM, right? So if we send, are we going to get anything? Yeah, we got a successful response. And if we go back to the response, we got something called security credentials, which is a folder. Let's try again.
That sounds important.
Exactly. Security credential.
These are the reps you have to put in if you actually want to find vulns, guys. It's not as easy as pasting a payload everywhere.
Exactly. So we've sent. Let's check again. We sent. And we also got another thing called VolnBank role, which looks like a file or something. So we'll try it again. Paste /VolnBank role.
You can see in real time as he discovers and makes his way through these directories that exist at a level he should not be able to access, is what's going on right now, guys.
Yeah, and as you can see, we've made a request and the server stored whatever thing that might be in VolnBank role. And if we look at it, guys, now we've been able to exfiltrate access key, and it seems to be an AWS key. We have the access key, we have the secret key, we have the role ARN. You literally have everything to sign in, to log in into the cloud environment of whatever company that you're testing and start escalating your privilege from there. Yeah. So thank you guys for.
Thank you so much. Yeah, that was awesome, dude. That was great. Thank you so much. I'm going to jump into chat and grab these few questions that are waiting while people type remainders for the end of the demo. Julia asked, how do you deal with a modern application? Because for 3 days, I'm doing bug bounty on a single website, which uses 3 domains to run one application. We call that a unified platform oftentimes. When I make single requests to Burp or Kaido, I see more than 5-6 requests sent, and every request looks complicated. Yeah, that's completely normal, man. If you're new to bug bounty, I'm going to suggest 1, either find a simpler platform to start with, or 2, just get used to spending time there. Because what the top hunters do differently from everybody else is they are intimately involved with their platform for a long time, years, right? To the point that they have scripts and stuff that they run that will let them know if infrastructure has been updated, right? If they're using an AWS anything of any kind, they know which version they're on. And if that version changes, they know the day that it changes, and they're hunting on it, looking for a vulnerability. And as you spend time on a platform, it's just like spending time in a real house, right? As you explore the rooms, you're going to remember what was in there. You're going to remember which hallways go where. So over time, all of those like seemingly disconnected dots that are going in random directions will start to look like a map to you. And once that starts happening is when you'll start making progress actually finding vulnerabilities. But for a new bug hunter, we're talking like 6 to 8 months of time, I would wager. Okay, hopefully that answered your question. Okay, let's see. How do you know internal IP addresses to add in the SSRF payload? There's a lot of different ways you can figure that out, right? Like you can nmap somebody and figure out what IPs they're using that are publicly facing and try to look within ranges that are nearby. If they're using things like AWS, there are certain IPs that cloud infrastructures use all the time that you can just look for. And I'll show a couple of those in a slide here in a moment in defenses. But yeah, like depending on what tech stack you're using, certain IPs are going to be used. Things like that is a good way to figure it out. And then doing exactly what Al-Amir did, right? Like if you find something public facing, you can start digging around in directories and looking for information related to internal stuff. Tony, will you still call out an SSRF as a lower risk if you are not able to exploit it? I would. I think that if there's evidence that the server is making requests to places that it shouldn't based on your payload, even if there's no impact, I think the devs need to be aware of that depending on the application and what that cycle looks like, because applications are changed and modified so often. And especially in like larger teams, enterprise orgs, you might have 30 teams working on various microservices, and one team might turn something off to work on something and then forget to turn it on. And that could impact you. With SSRF, I would say that's less likely to be involved, but the guy in charge of security should at least know it's a thing, I would say. Paying for OWASP is worth it once you get into serious stuff. Yeah, manual bit is quite tedious. Manual is very tedious. That's why APIsec exists. Do it automatically. Can you apply to my last question? I'm able to exploit cores, but unable to make HTML file for PSC. How to do it? I'd need more info on that, Monster. Come into Discord and give us some more info about the specific request and things that are going on so we can help you. Another topic I want to ask this important question. Is it possible to find SQLi in an API request in JSON and also in GraphQL? If possible, what are the errors and parameters to look for? So like JSON is just a data structure. Like looking for SQLi in an API request would be like what we're doing now, but you're putting an SQL payload, right? If the server is accessing, or the application in any way is accessing an SQL database, the idea is that your SQL payload will make its way to that SQL database and run and then allow you to do things with that database. So you're not really looking in JSON for anything related to that. It's more about looking for inputs and things, right? Like a login endpoint, right? They're going to have to go to a database and verify that your login matches to the password and all that stuff. So that's your opportunity to interact with it and inject an SQL payload. Okay, I'm going to bring my slides back on screen. Let's talk about prevention here for just a little bit. These are just some of the top level things and just quick bullet points, guys, on things that you can do to help protect yourself from SSRF. Input validation is really important, making sure you're parsing and validating URLs as they're coming in, right? There's all sorts of different ways to do that. A quick conversation with ChatGPT can educate you on that. Network segmentation can be really helpful, right? Never exposing metadata services to the application layer is a really big part of that. I think that third bullet point there is the most important one. Amir, if any of these speak out to you that you want to talk about, please speak up, go for it. And then let's look at monitoring and detection in the bottom right there. That's what I forget who it was. Somebody was asking about, like, how do you know which IPs to talk about? That's what I was talking about earlier, right? There are certain IPs that are just going to be in use, right? Because you're using things like AWS. And so like putting monitoring on those things so that you can see if people are trying to hit those IPs looking for things and being alerted when they do. Another great way to defend yourself from these sorts of attacks, because like you just saw with Al-Amir, typically you'll see somebody like pushing their way through directories one request at a time, figuring out where things are. And if those calls are coming in sequence from an outside IP that is not in your allow list, right? Then that's like, boom, you have a system in place to send an alert. The response validation is really awesome. Don't return raw responses to users. That's what you just saw happening in the demo there. Don't let people know what's going on once the server's doing its thing. They don't need that data, even if it's internal. If it's not something somebody needs to do their job, don't include it in that response. Okay, I think that's all I have for defense stuff. Sorry, I'm rushing through These are the sources for today, guys. I will share all of these with you. In fact, I might be able to just paste it in chat really quick here. Let's see if this works. And then, of course, it'll be like in the YouTube description. It's a little messy, but there are several links there you can go to. And then we got to plug a few things here at the end of our time. Join us on Discord, please. We talk about all kinds of awesome stuff in there. We do bug bounty stuff. We talk about OWASP Top 10. We talk about real world breaches. We help people in pen testing courses. Yeah, it's just an outstanding community. We also run our ambassador program in there, which is an opportunity for you guys to come in and really participate with APIsec more behind the scenes. It involves just like being a champion for AU, and in return, you get opportunities for merch, discounts on, and opportunities for like scholarships and exams, right? Not only like we have our APIsec monthly scholarship that we do, being an ambassador greatly improves your odds of being selected for that. It also gives you discounts on our store and exams should you want to purchase them for yourselves. We hire directly through our ambassador program a lot of the time. If we have internship opportunities, those go through the ambassador program first, all that good stuff. And then the last thing I want to talk about here is Bolt by APIsec. So this, if you guys haven't seen it, is a really cool new thing that we have going on. It's been demoed a few times. And effectively what it is, it's something that allows you to capture traffic as it's coming in from a base URL. So kind of what you saw Al-Amir doing in Burp and how it was showing him all the API requests that were being made. All of that would pop up right there where you see it says Bolt by APIsec. You get a live feed of the traffic as it goes through your network. If you were to right click in your browser and click inspect and go to the network tab, it's basically like a hyper improved version of that allows you to filter data, look at a specific URL so you can ignore all the noise coming from Google ads or Firefox web services and things like that. Actually, it's only a Chrome extension right now. It'll be in Firefox soon, but it is in beta. And if this is something you'd like to test out and help us improve and provide feedback for them, you can go to the link on screen or scan that QR code there. And what that'll do is allow you to request access. It's not just going out to everybody yet. We do have to approve you to be in. And once we get to a stable release, which is going to be announced really soon, I actually almost announced it today, but we're like this close from stable state, then it'll be something that you guys can really get your hands on in mass and play around with. And you'll see that we're adding a lot of stuff for my hackers in here. Imagine if Burp Suite told you like all of the different endpoints that the parameters were being used in. So like you click on an endpoint, it's got 5 parameters in use in the body. And then it's, hey, just so you know, the other 5 endpoints on this API also use these parameters, right? And it's giving you insights like that you don't get in Burp automatically. So super cool and fun to play with. And then of course, make sure you are registered for our next session, which is going to be super duper amazing. We're going to be doing Broken Auth with Teresa Pereira. I know you guys are familiar with her. She is one of my favorite people in the space, honestly. She does a ton of social engineering stuff, which leads to a lot of broken authentication stuff. So I'm really excited to see what she has to say about this. The link, so let me grab for the recording, is going to be, let me go find our YouTube page really quick. There we go. I thought that was it. No. So all the recordings will be here for all 10 of these, you guys. They'll probably start popping up this week or next week for the ones that have already been done. Keep an eye on there. And then, of course, follow us on LinkedIn, too. As we post these things, they always pop up there as well. Be respectful of your guys' time. We've already gone over. Thank you so much, Al-Amir, for showing up today, man. I know that you were under the weather and you still came and absolutely crushed that demo and got us a lot of great engagement in chat. So thank you.
No problem. Thank you so much for the opportunity. And thanks to everyone who joined and stayed to the end of the session.
Yeah, huge thank you to everybody who stayed and participated. We love spending time with you guys, and we will see you on Thursday. Have a great rest of your day.